Hi, my name is Max, and I have 25 days until my exam. Getting real close. Okay, so this question has a lot of information kind of thrown at us, but what's good about it, it has the same interest rate. So let's make our time diagram so we know what exactly is going on. Bam. Nice and straight. Okay, so from time 0, I have my notes right here. So from time 0 to 9, we have payments of 1,000, right? So it says payments of 1,000 starting at the beginning of each year. Okay, and then we have the payment of X at the end of 15 years. So dot 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 15, right? We have X. And then it says at the end of 20 years, merely use accumulated balance to fund a perpetuity immediate of annual payments of 2,000 per 10 years and 1,000 per year thereafter. Okay, so this is kind of where it gets a little tricky with the numbers and time. This is where I originally messed up. So we have time 20, right, and then 21. So we have perpetuity starting here. It's a perpetuity immediate, so it's important that the payment starts at year 21, right? And then that goes until year 30, right? Because it's 10 years. Let me read this. Payments of 2,000 per 10 for 10 years. Okay, and that goes to 31, and then it's an infinity, like it keeps on going forever. So there's a couple ways you can approach this, and I know there's different ways in the manuals that show you. The way it makes the most sense for me is writing it as such like this. I had a pause, I don't remember where I was at, so I'm going to start from here, which I think is where I left off. So the ways to, I guess, solve for X, there's many different ways. And this is the way that makes most sense for me. There's a bunch of different ways in the manual if you look it up, but first we have cumulative value of an annuity due, right? So we have S angle 10 at the 5%, right? 5% for everything. So that brings everything to the time 10, right? Because comparison date is one payment after the last payment date. Then we need to take that times 1.05 to the 5th power, right, to get it to time 15, because time 15 is our comparison date. That is what I decided to do. And then we have, actually no, I lied. I'm not going to do that because that wouldn't make any sense. Good catch if you saw that. That is not going to be a comparison date. A comparison date is going to be time 20. You could do 15, but it's going to be easier if you do 20, at least the way I'm doing it. So we have, no, bam, okay. Now this makes more sense, sorry. So this is accumulated to time 20, and then we have the payment plus payment of X accumulated for 5 years to 20. Then you can set that equal to the perpetuities, and there's a couple of different ways you can view this. You can view a perpetuity of 2,000 for 10 years, or annuity for 10 years, and then it continues for 1,000. Or you can do one annuity for 10 years and a perpetuity for... I just kind of repeated what I said. I'm sorry. Let me just write it for you, and then hopefully it makes sense, because I don't like explaining this. It's kind of hard to do. So we have 1,000, A angle infinity at the 5%, plus 1,000 at A angle 10. That's hard to see. I'm sorry. So we have angle 1,000 for infinity, right? So 1,000 payment from 21 on, because that's just kind of how it is. And then we have a payment of 1,000 from time 21 to 31, and it works out. So now we have one equation and one unknown answer, which is X. And it's kind of hard to solve this with your TVM calculator. So you can transform that into this by taking it times one interest rate period. So S angle 10 at 5%, take that times 1.05, right? Because that's how you change the annuity due, cumulative value annuity due to a normal one, which would make this, so if you get rid of this, right, if you actually do the math, this turns out to be 1050 S angle 10. And then everything else is normal. So 0.05 to 10 plus X to that. And then, yeah, so the rest of it is, I guess, pretty simple and straightforward. So I'll give you the final answer, which is, I have it written down here. We have X to equal 4,865, I think roughly. I think that's rounded, but yeah, if you do all those, you should get the answer. And yeah, this is kind of a hard one because there's a lot going on and I'm kind of scrambled. So apologize for that, and I'll see you in the next video.